So up to now we have completed the various characteristics of sewage, design of sewers, and then we have started now with the sewage treatment. In the sewage treatment we have completed this commutators and macerators, screening and grid chamber. Now in this video we will be seeing the detritus tank and the skimming tank. So let's start with the detritus tank. Detritus tank. So it is almost similar to grid chamber. So both are same with only one difference. And what is that difference? So grid chamber. So what it removes? The grid chamber. The grid chamber removes larger inorganic particles. So it removes the larger inorganic particles. Now when it comes to the detritus tank, it is also a same tank, same function. Only difference is it removes fine inorganic particles. It removes the fine inorganic particles. So this is the main difference, that is which type of particles they remove. So grid chamber removes the larger inorganic particles, detritus tank removes the smaller inorganic particles. So if we just draw the cross section here, so this is the tank. So this is an inlet for the tank. This is the outlet. The sewage comes from the inlet here. It flows slowly towards the outlet, and during its flow, whatever the sediments are there, these sediments settle here inside. Okay, so the sediments are settled here. If you see the cross section, then it will look like this. So this is the inlet and outlet. This is the sewage level which is present inside, and whatever the grids is there, so that grids are settled here, or we can say whatever the smaller and larger inorganic particles are there, that are settled here. And this pipe is the sediment removal pipe. So there are two pipes here. One pipe is the inlet and outlet pipe in the cross section, and another pipe is this sediment removal pipe. From here the sediments are removed. So this is all about the detritus tank. Now let's move to the next topic, that is skimming tank. Skimming tank. So skimming tanks are designed to remove oil and grease from wastewater. So whatever the oil and grease is present in the wastewater, it is removed by the skimming tank. So if this is not removed, then this oil and grease this oil and grease interferes with the BOD removal process. So it will interfere with the BOD removal process. So we all know that specific gravity of oil, or let's say specific gravity of grease, so it is less than specific gravity of water. So as it is less than water, they will not settle, or they will not get sediment, or they will not settle inside the water. Hence they will not settle in water. So to remove this, to remove oil and grease, to remove oil and grease, compressed air is applied, or it is, let's say, compressed air is applied from the bottom of the tank, of the bottom of the tank. Okay, so when this air comes in contact with it, this oil and greasy particles, they produce a flock, and they are produced, or we can say whatever the oil and grease is present inside the water, it all gets collected at the top surface. As oil and grease has less specific gravity, hence they will be present on the top surface. So let's draw it quickly. So this is the inlet. So this is outlet discharge, and this is inlet. Okay, so now look carefully. So this is our skimming tank. The main purpose is to remove the oil and grease. So when the sewage comes inside, so it gets occupied here. Okay, now when it is getting occupied continuously from the bottom, compressed air is blown. So from here the compressed air is supplied to the water. So this is compressed air. Now these bubbles will start coming here. Okay, so whatever the oil and grease is present, in this sewage, so this all will be coming to the topmost portion of the sewage. So whatever the oil and grease is there, so let's say this is the oil and greasy layer, so it will be collected at the top. So oil and grease. Why? Because the specific gravity is less than the specific gravity of water, and after some time it will get collected in this separate chamber. Now for this there are certain design parameters that we have to see. So design of skimming tank. Design of skimming tank. So the first formula is for the surface area of skimming tank. Surface area of skimming tank. So let's say this is A, and this A is calculated as 0.00622 into Q divided by V, and this V is, we'll name it as VR, where VR means liquid rise velocity, and it should be in meters per minute. It should be in meters per minute. Q is the flow rate. Q is the flow rate, and it should be in meter cube per day. And the second one that we should know about the design, for the design of the skimming tank, is the detention time for skimming tank. So the detention time is 3 minutes to 5 minutes. Okay, so these are the two formulas that you should remember while designing the skimming tank. So the surface area of skimming tank is calculated by using this formula. Now you have to pay attention here specifically for the units. So this units of area is in meter square. So whatever the area you will get, it will be in meter square. But for that you have to substitute the value of Q in meter cube per day, not meter cube per second. Similarly, velocity should not be in meter per second. It should be in meter per minute. So if it is given in meter per second, you have to convert it into meters per minute and then substitute in this formula. Okay. So the units play a very important role in the environmental engineering. So with this, solving the numericals, you will understand that by looking at the unit only, you should be able to tell which quantity it is. So let's say somewhere it is given as meter cube per second. So you should quickly understand that this is a discharge. Okay, it is a unit of discharge. So in a similar way, the units are very important. So try to focus on the quantity which you are calculating and also on the unit which you are substituting. So this is all about the skimming tank.